Hello, everyone, and welcome to Math with Mike. Today's lesson is about finding the area of triangles and other polygons. I'm thrilled to be your teacher and that you are here to learn with me. In this lesson, I'm hoping to show you how to find the area of all types of triangles and show you how other shapes can be broken down into smaller triangles, which can then make it easier to find their areas. I hope to call on some of the knowledge that you may already have about triangles and other shapes to help you understand how this works. First, though, I have a question for you. Have you ever been with your friends hanging out at the football field playing pass and wondered, hmm, how many Chicago style deep dish pizzas could I fit in this football field? No, maybe. Maybe it's just me, but I do got a big belly and a big appetite. So this question has come into my mind once or twice. You may be thinking, wow, that's kind of a crazy idea, but the answer to this question may be easier and more simple than you think. Now, I want you to think of some shapes that may have triangles hidden in them somewhere. All right, maybe you came up with a square, a rectangle, maybe a parallelogram. All those would be correct. Now, I want you to think of some real life instances where you may see some of those shapes or some of them put together to make bigger shapes. I'm sure you guys were able to come up with some awesome ideas, but the one that comes up to my mind when thinking about this is the classic cartoon house or the front of a house, which is like a square with a triangle on top of it, with a triangle roof. These are just some ideas that I wanted to throw out to you to get your brain in gear and get you thinking of how we can see these shapes in real life and how multiple smaller shapes can be combined to make bigger ones. Now, let's get into the basics of area now that we got your brain warmed up. You can think of area as how many square units you can fit into a larger area, whether it's a square, a triangle, or a rectangle. So, in order to find the area of a particular shape, all we have to do is count how many little squares can fit into a bigger shape. Let's take this big square for example. If this square is 1 square unit of area, we can assume that by drawing 4 of these little squares inside of this big square, we can simply count them up and assume that there are 4 square units inside of this bigger square, meaning that the area of this big square is 4. All right, all right. Now, for some of you, this may be a basic review, but it's always good to refresh your memory. You may be thinking, okay, that makes enough sense, but this could take a long time with bigger shapes. And you're absolutely right. This is why we have this brilliant formula that helps us calculate the area of triangles easily. With this basic formula, we are able to calculate the area of a triangle given the base and the height. The base being the bottom part, and the height being how tall the triangle is. This does away with any meticulous counting that we might come across with this original method. I just wanted to show you what the thought process is for how we're calculating area. Now, let's try one together. So we can assume that the area of this triangle equals 1/2 times the base, 3, times the height, 4. Now, if you're following along, you would get 1/2 times 3 times 4 equals 12. 12 divided by 2 is 6. So the area of this triangle equals 6. This simple formula can be applied also to other types of triangles. Take this equilateral triangle, for example. Here, we can see that the base is 10. So plugging into our equation, area equals 1/2 10, and the height given 7 times 7, we get area equals 1/2 times 70. And with a simple calculation, we can see that the area of this equilateral triangle will equal 70 divided by 2, or 35. Let's think back to the house example that I mentioned in the beginning. See, if we were asked to find the area of the front of the house on its own, it might seem a little bit daunting. But notice if we simply separate the house into two separate shapes, a triangle and a rectangle, we can easily find the area of each of these shapes and then simply add them together. Thinking back to our area of a triangle equation, we can plug in the given height and base for this triangle. Area equals 1/2 times 48, and we can see that the area of this triangle above will equal 24. And now we know rectangles, as the equation for this is just area equals base times height, and we can see that this area will equal 96. Now all that's left to do is simply add these two areas together, and we can get the entire area of the front of this house. And with some simple mental math, or calculator if you want, we can see that the area of this front of the house equals 120 square feet. Now that you have a good feel for how to deconstruct a larger shape into easier to handle shapes, let's apply that concept to an even more complicated looking shape. Although the shape may look very daunting at the moment, we can think of all the shapes that we already know how to conquer and look for them in this one. We already have all the tools we need to conquer this one together. If we move this to the side, we can see how easily we can deconstruct this and attack this shape by shape. Now, let's look first to this triangle here. We know for the first triangle that our formula is going to be our trusty 1/2 base times height. Simply plugging in 5 for the base, 3 for the height, we get 1/2 times 5 times 3, or 1/2 times 15 equals 7.5. Moving on now to this rectangle down here, which is just our classic base times height without the 1/2, because this is a full rectangle. We can get 5 times 10 equals 50. And now do the same exact process for the bottom rectangle that's coming straight from here, and this rectangle coming from the bottom here. And now, going back to our two triangles on the side here, we can see that they are identical triangles with a base of 3 and a height of 2. So for our two small triangles, we have 1/2 times base of 3 times height of 2, or 1/2 times 6 equals 3. And now with some simple addition, we can look at all of the areas of each individual shape that we took the time to calculate. But remember with this one, times 2, because there's two triangles, and add them all together. Add it all up. 3 plus 3 is 6, plus 5 is 11, plus 10, 21, plus 50, 71, plus 7.5, 78.5. To summarize, we took this massive shape right here, kind of resembles a spaceship, a real-life example, and broke it down into 1, 2, 3, 4, 5, 6 different shapes, calculated each area individually down here, and then added up all of those areas to find the whole area. You've been doing so awesome so far. Let's keep it up. Now is the time in the video for you to put all of your new knowledge to the test. We have covered a lot so far, but I know you can pull it all together. And here's your 3 quiz review questions. These are going to test your knowledge as they get progressively harder from the beginning to the end, and they touch on all of the aspects of our lessons today. Congratulations on getting through your first test on this material. Now let's go through the solutions together so you can check your work and see how to correct any mistakes you made. So our first one. This one should be easy review for you, as it's just our trusty formula,
1/2 base times height, plugging in for the base of 8 and the height of 6 into our formula here. 8 times 6 divided by 2, 24 square feet. We can see that we can attack this by breaking it up into the triangles on the ends and a rectangle in the middle. First, let's attack our triangles. So here we can see that the base and the height are the same, 4. So we can plug back in for our area equals 1/2 base times height formula and find that 4 times 4 is 16, divided by 2 is 8. But remember that we have 2 triangles on the ends of this parallelogram, so we should multiply by 2 to get the total area that those triangles make up, 16 square feet. Now, moving on to our rectangle here, we can see that this length 10 makes up for the whole length of the top and bottom. But since we already calculated the area that this 4 makes up, we don't want to double count it. So before we calculate the area of the rectangle, we want to be sure to subtract that 4 out from the top length to get 6. Now that we have the correct length of just this area of the rectangle, we can see that if we draw another dotted line here, we have a nice, neat 6 by 4 rectangle, which we have calculated here. 6 times 4 is 24. And now all that's left to do is add up the 2 areas from the 2 triangles and the rectangle. 24 plus 16 equals 40 square feet. Great job so far if you've gotten this far. I'm very proud of you. And now for the most challenging one of the day. So when looking at this, you can think, wow, there's a lot going on there. And I agree. It kind of looks like maybe an old NASA spaceship or something like that. I love airplanes. I love aircraft. So that's where I got the inspiration for this shape. Hopefully some of you share the same passion as I do. But looking through this, we can see that we can break it up into multiple shapes. I see 2 triangles, 2 smaller rectangles, and 1 big rectangle. So, as we've done before, let's just attack it shape by shape. First, we can look at triangle A here. We can see that this triangle has a height of 3 and a base of 4. Using our trusty 1/2 base times height formula, we can see that 1/2 times 3 times 4 gives us 6 square feet. Using that same exact strategy for this triangle, only with different numbers, we can plug in 5 for the height, 3 for the base, and get that 1/2 times 15 equals 7.5 square feet. So look at that, we're already halfway through this shape, and all we were doing is using that same formula that we learned in the beginning. Now, moving on to these small rectangles down here. 2 times 1, easily 2, but remember, we have 2 of them, so we should multiply by 2 to make sure that we have 4 square feet, accounting for both of these rectangles. Now, maybe the trickiest part of this whole problem is the calculation of this big rectangle. So, originally, if you're looking at it, maybe you're wondering, how can I possibly calculate this if this side is longer than this one? But remember in this parallelogram example above, how when this length 10 was for this whole top length, and then we subtracted this 4 because we already counted for it, we can do the same exact process down here and simply take off this 5 off the end from that 20 feet, because the 20 feet calculates that whole length, and understand that this rectangle can easily be calculated for using subtracting 5 off of that length of 20. So, using this height of 3 for the edge of the rectangle, we can see that 3 times, sorry about that, busy guy. We can see that 3 times 20 minus 5 will give us 3 times 15 equals 45 square feet. And now, 6 plus 7.5 plus 4 plus 45 equals 62.5 square feet. Fantastic job.
I'm so proud of all the work you've done today. Today, you discovered how to do a number of things. First, you found how to find the area of all types of triangles. Then we figured out how to decompose larger shapes into smaller triangles, squares, and rectangles to make it easier to find the area. Finally, we tackled challenging, complicated shapes by using the strategy we just talked about. Remember that ridiculous pizzas in the field example that I mentioned earlier? As long as you have the proper dimensions, you now have the skills to find the answer to that and so many other wild and fun scenarios that you may think of in your everyday life. I want to thank you so much for spending your study time with me. You killed it today. I truly hope this lesson helped you get a better understanding of how to solve the areas of triangles and more complex shapes. We'll see you next time on Math with Mike.